Welcome back. In lecture 33, we will cover trip production and attraction. This is part 1 of the lecture. So, the different concepts that would be covered is growth factor model, then regression model, and within regression model, we will look into trip production and trip attraction separately. So, the growth factor model is it's a very simple way of predicting trips for a household or a zone for a target year, and we do that by just multiplying the base year number of trips either produced or attracted to that particular zone, or if it is for a particular household, we can predict the number of trips produced by that household using just a produced by that kind of household group by multiplying it with a simple growth factor. Now, the growth factors can depend on several explanatory variables and changes in their values during the period between base year and target year, such as we understand that population, total population of a zone, the household income, vehicle ownership, land use characteristics of the zone, all these things play a role in the trip generation or trip attraction process. That means, if the number of people are more, then automatically the trips will grow. If the income of that particular zone or that household group or the socioeconomic group increases, then automatically also we will find that the total number of trips will also grow, or total trips generated would also increase. So, in that sense, we determine the growth factor where we actually develop, like over here in that example, you can see the growth factor is target year population and into target year income divided by base year population into base year income. So, instead of one variable income or population, we have taken a product of both the variables, and we can keep on adding other variables which we feel appropriate for this particular prediction. For production it could be different, for attraction it could be different. So, we will choose the variables which may play a role in the influencing the production or for that things that we are predicting, and actually use it to determine the growth factors, which could be directly multiplied with base year trips to get target year trips. So, we will adopt a growth factor method when we lack detailed zone wise and household wise data. So, this is a easy way of determining future growth of a particular area. Alternatively, the more popular model is popular way is to develop a regression model. Regression model, as we have discussed earlier in the previous lecture, that a regression model establishes a relationship between a dependent variable and an independent variable, and with many independent variables, or it could be a single independent variable as well. So, over here the dependent variable is either total number of trips produced or attracted to a zone. So, this is if we use a aggregated approach, whereas it could be also the total number of trips either produced by a particular household category, that could be also predicted using a regression model. So, we can also say that the total number of trips attracted to employees of based on the number of employees in a particular zone, that also could be put inside a regression, could be also predicted using a regression model. So, linear regression, we usually use linear regression, and it establishes the relationship between independent and dependent variable, and it is using a linear function. And as we have discussed earlier, using the method of least squares, linear regression is used to determine the coefficients of the dependent variable. So, there could be many dependent variables which is used in predicting an independent variable, and we determine the coefficients of this particular independent variables by doing a least. We can do, if it is a linear regression, then we use the least square method, and as we have discussed earlier. So, these are different variables. We can either go for a straight linear fitting, curve fitting, or we can also go for this kind of curve fitting where it is a cubic function. So, it could be a nonlinear regression as well. But here also we do it by minimizing the sum of squared deviations and that is all, that process remains almost the same, and that is used to determine the coefficient of this particular equation, or for that those independent variables from a particular equation form. So, this is a nonlinear equation form. So, it could be either a linear equation form or a nonlinear, it could be a linear regression or a nonlinear regression, but the most popular obviously is multiple linear regression. So, how do we select explanatory variables? We have the ones which has got a linear relationship directly with the dependent variable, that is the one that we will choose, and nonlinear relationships could be again transformed into a linear relationship by taking a log transformation, as we have seen. If this is the equation y equal to a into x to the power b, there we can take a log of y, and log of that becomes log of a plus b into log of x. So, in this case we can take a log transformation, and then we can again take plot both y and log of x instead of, and we can include them in the equation as well in our regression equation. So, independent variables should be linearly related to the dependent variable, this we have already learnt earlier, and it should be highly correlated with the dependent variable. Of course, it should be correlated with the dependent variable, but just the opposite for all the other independent variables. That means, independent variables must not be highly correlated between themselves, and this could be checked with the variance inflation factor or with the Pearson bivariate the correlation coefficients. And another thing that we need to be taking care of is to check the explanatory variables should be able to be projected in the future period. It should not be such that we cannot project them in the future period. So, that needs to be checked beforehand. And then the multiple linear regression model takes this form, where qi equal to, it's basically this is the form of the regression model, and this is the form of the linear regression model. So, ai's are the coefficient of the regression equation, which needs to be estimated through regression analysis. So, when we are talking about multiple linear regression model for tree production, then we could do it both for a disaggregate model and also for a aggregate model. Now, aggregate model basically means a model which predicts the total number of trips produced from a particular zone. So, in that case, the zonal characteristics will play a role in determining what is the total number of trips produced from a zone. Now, zonal characteristics means the independent or the explanatory variables. Now, as we can understand, we can develop this kind of models for different kinds of trips based on different trip purposes, like for example, home based trips, maybe the home based walk trips. We can say that the population age groups living in a particular zone, the residential density of a zone, the distance to CBD, accessibility of that zone, residential land use, building area, all these things could play a role in predicting the total number of home based walk trips generated from a particular zone. But obviously, certain things would be correlated, like for example, the total number of people living in an area could be correlated with the total building area. But or it may not be. If the building area varies because there are a lot of income groups living over there with different building area, then probably it may also vary. Then population age group is considered because different age groups has got like age group which is below 15 years is not going to any work, and similarly age group which is above 65 years, they are also less likely to work. So, that means dividing the population into the age groups probably gives us more subgroups of the population, and each subgroup could have different coefficients in predicting the total number of home based walk trips. Similarly, residential density may play a role, and then distance to CBD or accessibility, this too may be correlated, this may also play a role, and so on. Now, this is for home based trips. Similarly, there could be other home based trips, and then there are non home based trips like walk trips. So, for over here non home based trips basically means they start from work and then that is sort of a meeting, a person goes for a sales call and so on. So, these are non-home based trips. So, probably they will go to some another from one commercial area to another commercial area. So, over here the variables chosen are commercial density, number of employees, distance to CBD, accessibility, commercial land use, building area. Again, commercial land use may be or correlated with building area, or both of them may be correlated with the number of employees. And then we can also have home based shopping trips, which could be related with population age groups, residential density, accessibility, residential and retail land use, and retail area. Now, even though it is home based shopping trips, people may choose to travel both near and far for shopping. So, we have taken both the population or the zonal characteristics as well as residential land use as well as retail land use. So, many people may be willing to shop in the local area as well. So, retail land use in that particular zone is also considered while making a regression model. So, these are the different likely parameters which could be included while developing a regression model for number of trips generated from a particular zone. So, this is based on zonal characteristics. Now, similarly, we can also have a disaggregate model where we predict the total number of trips based on different household types. So, in that case, for home based trips, personal or household characteristics and zonal plot characteristics can play a role. So, personal household characteristics could be age, income, vehicle ownership, household structure, family size. This may play a role in determining the number of trips that result from for a particular type of household, or it could be value of land, land price, residential density, distance to CBD, accessibility, residential land use, residential building area. So, these are the variables which could be also playing a role in determining the total number of trips produced by a particular socioeconomic group in a area. So, that actually, so this could be the household level prediction model based on household characteristics and zone level characteristics, and this could be a prediction model based only on zone characteristics. Similarly, for trip attraction, we can also have different explanatory variables for a multiple linear regression model. For example, home based walk trips, that means number of home based walk trips attracted to a particular area. Here we can use the number of employees, commercial and retail density, distance to CBD, accessibility, commercial and retail land use, building area. These are the things that may influence the total number of home based walk trips attracted to that particular area. Why? Because people may be it may be depending on the total number of employees, but if it is primarily a commercial area, then commercial and retail density plays a role, because that determines the total number of employment in commercial and retail sector, and also the total number of other kind of people who comes to clean, and all these things could be also determined from land use. So, that is why all the other land uses are also important. Then in non-home based trips like walk trips, then again this is almost similar to the trip production model, where the number of trips attracted, non-home based walk trips attracted means again it depends on the commercial and retail density, number of employees. So, this is again a work area where trips are attracted. So, that is why these are the variables which are actually playing a role. And finally, number of home based shopping trips that are attracted depends on the total retail density, accessibility, retail land use, and retail area. The more is the retail area, more number of people would be attracted to go to that particular zone to shop. So, this is the different variables which play a role in explaining trip production and attraction. So, similarly, freight trips generated and attracted could be also predicted. So, this could be predicted based on number of employees, industrial, commercial and retail land use, and also the building area that is there in that particular zone, because this actually determines the number of freight vehicles that would be both produced as well as attracted to that particular zone. So, categorical, unlike dichotomous zeros and ones or continuous variables, categorical variables can also be included in regression, as we have already discussed. So, we can dummy code them. So, weather like sunny, cloudy, windy can be represented using two dummy variables, sunny 0 1 or cloudy 0 1. So, this is another way to include this particular categorical or qualitative variables in regression equation. So, this next we show you an example of a multiple linear regression model. So, these are some of the this is for a trip attraction model, and here we see the different variables that has been considered. So, on this side we see total trips produced from a neighborhood for ith trip category. All the product variables are given. See how the variables have been listed: TRP underscore gen underscore I. Variables are it's in italics, and then we have used an underscore to connect between the different components, what components that we have used, and the variables should be meaningful. That means it should, after reading the variable code, people should have a basic understanding of what exactly is it trying to represent. So, that is why we have used variable codes which are which have some components from the actual variable. So, total trips produced from neighborhood for ith category by males and females, these are all considered, and total trips attracted to neighborhood for ith trip category, total walk trips generated from neighborhood, total walk trips attracted to neighborhood. So, these are the different variables that are being considered. Then different demographic characteristics that has been considered. These are all zonal characteristics: total population in the zone, total female population, male population, total female population of ith age category, male population of ith age category, then population based on different age groups, not with gender wise categorization has not been done. Then total number of employees in a neighborhood, total number of business employees in a neighborhood. So, there are two categories of employees, and then land use categories are there. Total neighborhood area, which is a continuous variable, which or it could be area of residences, then area of greens, area of business, area of public agency, all the commercial variables, and then religion and residences and so on. Total floor area also is considered for different kinds of buildings: office buildings, public agencies, residences, commercial institutes and so on. So, if you see, we have considered both building area as well as land use, but probably both are correlated, whereas we have also used population for different age groups, as well as we have subcategorized them as per gender. So, we at the beginning of the regression, we are not sure which one will give us the best possible result to predict the total number of trips attracted to a particular neighborhood, or a particular zone. In that case, we should test different combinations of different variables to see which one gives us the best possible results. And after checking for all the assumptions and all the other checks, and then we need to find the most appropriate one, appropriate regression, which is theoretically both consistent as well as it is also statistically consistent. So, that is how we develop a linear regression model. So, over here this is the final results of the model, where we predict the total trip attracted to a particular zone. These are walk trips for business purpose. So, the regression equation shows that total trips attracted is equal to 132, this is the intercept, plus 0.023 into, this is the coefficient for floor area of businesses, plus 0.046 into floor area of public agency, plus 0.092 of population. So, this is the best regression, this is the best possible result that we have got, and we found that the regression is around 0.8 adjusted R square is 0.747, and the total f value is significant. So, that means the model structure is also proper, and we have an intercept at 131 and the different variables, and we see that when population of a zone increases, then trip attracted to that zone for different purposes increases, but it has got a very small role to play, whereas primarily it is rated with total number of buildings, floor area for businesses and public agencies, which attract people to come to work in those particular areas. These are the explanatory variables that are included in the model. So, these are some of the references you can consider. So, to conclude, Multiple linear regression is most commonly used to develop trip production and attraction models. Selection of independent variables should be logical and should reflect the underlying causes and contributors of trip generation or attraction based on observations from the real world. The final model should be simple and should be easy to apply in other areas considering data requirements, explanatory power and robustness. Thank you.